All right. So are there any questions about the current homework assignment? The one that is due next Monday? Some people are done already. Sorry?
Will you do it for us?
You just about did
After
that.
the due date, yes.
I think it's just a quick question.
Yep.
It just keep me from having to go look it up, but it's actually never mind. I gotta look at something first. I'm not quite sure what it's doing yet. I don't know what to ask yet.
Okay, all right.
Thanks.
So you need to formulate your question.
Yes.
Okay.
So your question is, what do I need to ask?
Now, last time we started to talk about the select call, because your next homework assignment is going to have the select call. So what I would do is I'm going to open up the next homework assignment. I will not assign it yet, so it's not going to be assigned, but we'll take a peek at what it is about so that you can get ready for socket 2, because it is the second socket homework assignment. There's also a socket 3 too. Okay, so let's take a look at the socket 2 homework assignment. The socket 2 homework assignment is based on socket 1. And people who cannot finish socket 1 can use my solution of socket 1. I will disclose that solution on Monday. In this case, I would use a makefile. Okay, so we have to get into makefiles in socket 2 as a homework assignment. The makefile should have a clean target to delete all objects and executable files. We'll talk about the makefile later. So you can say make it clean to remove all the object files and executable files, and then use make by itself in order to compile and link to create the executable file. And in the case of this one, after all 3 clients connect, the server does not send the circle is complete message. Instead, the server would do the following. It would listen to all 3 connections from the clients. So right away, we know that the approach that we are using in this particular program is not going to work. Because you cannot just stay in a loop and say, I'm going to wait for you, then I will wait for you, then I wait for you, because which client is ready to talk first is arbitrary. Okay, so that part makes it a little bit harder. You want to broadcast any incoming content from any one client to all connected clients, including the client that is originating the content. In other words, we are trying to implement a hub. Okay, in network terminology, this is a hub where anything coming in, you just broadcast it to everybody else, or everybody, not everybody else, it's everybody. You want to keep track of which client connection is still active. In other words, clients can drop out on their own. Clients can decide, okay, I'm not playing anymore, and I decide to check out. So when a client checks out, the server has to keep track of that and say, oh, okay, this client is no longer there, so when I listen, I better not listen to this guy, and when I broadcast, I better not broadcast to this guy either. When all 3 client connections are closed, so when you only have 1 left, you still have to do the echoing even though there's only 1 client left. When all 3 clients connections are closed, then you want to close the endpoint socket, unlink the socket file, create it, and exit. Okay, any questions? Yep.
So the server the server waits for 3 connections before it starts listening then?
That is correct.
Okay.
On the server side, on the client side, it's really simple. What you do is you echo everything from standard in to the socket connection. So whatever you type on the command line or pipe in using the pipe or the redirection symbol, you have to send it to the connection. And everything that you get from the connection, you have to echo that to standard out, which is what you are doing already. Okay, so there are two-way. It's a two-way echo. It's a two-way echo mechanism. Whatever you see from the keyboard, send it out through the connection. Whatever you receive from the connection, send it out to standard out. Okay. So once again, even on the client side, you need to use select, because you don't know which event is going to come first. Am I going to see something from standard in first, or am I going to see something from the socket connection first? We don't know, because that's asynchronous. There's no way to tell whether you will see which one you will see first. And all connections should be set up to be blocking. So we're using a blocking call for read, and we're using the blocking call for write. By default, they are blocking already, so you don't have to do anything special for those operations to be blocking. Yep.
Did you start recording?
I believe so. But let's check. Yep, it is recording. Let's check this the volume too. Yep, it is recording.
And did you check your size?
Ah, very good. Yeah, we only have like yesterday's notes here, so we should have plenty of space. Yep, we have 8 gigabytes left. It's good for about 5 lectures. But I should probably remove those files too, so I'll go ahead and remove things from yesterday. There we go. Now we have even more space. We have 11 gigabytes. Very good. Okay, to accomplish this, you need to use the system call select, and we talked about the select call already. Use man to select to read the manual page of this system call. To simplify matters a little bit, you don't need to use the timeout feature of select. So in sockets 2, in this particular project, there's no such thing as timing out. If a client has nothing to talk to you, if all 3 clients have nothing to talk but the connection stays open, just wait, okay? Just wait indefinitely. There's nothing you have to do and say that, oh, okay, nobody's talking to me in 5 seconds, I better do something. No need to do that. That's reserved for socket 3. So timing out is kind of, it's left for socket 3, so we'll just kind of keep it that way. To simplify your program even more at the expense of performance, I would suggest that you read and write byte by byte. Simply because when select unblocks, it only guarantees that there's 1 byte to read or 1 byte to write to. If you try to read 2 bytes, it may block the read call itself. Select doesn't tell you how many bytes are ready to be read. It only tells you that there's at least 1. So if your program reads 1 by 1 and use select as a guard to make sure that you don't do anything unless there's something to do, then everything should work fairly easily. Okay, and also it's because on the client side as well as on the server side, you're really just echoing stuff. So for the most part, you don't really have to deal with multi-byte read or multi-byte write. There's nothing that naturally leans itself or lends itself to reading or writing multiple bytes. So byte by byte read and write would be the best option because it just simplifies the logic of your program a lot. The man page also includes a simple example to illustrate how to use select for a very simple task. Read that first, okay, and make sure you understand that sample program. So I would go to that man page next. You should also read man select underscore tut for tutorial, for a longer tutorial. It specifically explains how end of file can be detected and handled, which you also have to do. There's also a much more elaborate sample program in select tutorial. The program is due on Monday after spring break, and I think in our case it probably works out about the same too. It depends on when we actually finish all these topics. I recommend starting on this one early and utilize smaller programs to test how to use the select call properly, and also use revision control. It's not required, but I think it will help. You can, if you want to, use my solution of socket 1 as a starting point, and all standard disclaimers apply. In other words, I may have bugs in my program. I do not guarantee my program is 100%. You only use it as a template. Are there any questions about the next homework assignment? It's not assigned yet, so don't worry about it. Right now, we only have 1 homework assignment, that is current, and that's without the use of the select call. Nothing about this program. Now, when you look at this program, it obviously is more complicated than the one that you're writing right now, because now you have 3 clients, and you need to keep track of which client is still alive, because if a client decides to, let's say I open up a terminal on one of the clients, and as I type, whatever I type will be echoed to the server, through the socket to the server. The server will broadcast it to everybody, and then everybody will display it, through standard out. If I press Control D on the console for the client, that will send a file to that client through standard in. Okay? As a result, the client will stop and say, okay, I am terminating. When the client terminates, it will automatically, when you close a program, it automatically closes all the file descriptors automatically. So as a result, the client will close the connection. The server will recognize that the connection is closed. And then the server has to keep track of that and say that the connection to that particular client has closed. From now on, I will not try to listen to that particular client. Okay?
So is it, we're keeping track of if they push Control D to close or to remove the file descriptor or the?
Nope, you use Control D to, when standard in closes, which means when you see end of file from the standard in, you also have to close the connection, the socket connection itself, and then you just exit the client program. Okay?
So that's on the client side. That's on the client side.
That's on the client side. Yeah, the client side is considerably easier to deal with because it doesn't have to broadcast, and it doesn't have to keep track of the state of the server. From the client side, you can. Oh, I forgot to specify one thing. No, I don't have to specify it. If the server dies, the client doesn't have to handle that particular case. We can make the assumption that the server will stay alive until all clients quit first. So you don't have to handle the special case where the server decides to quit first and then the client has to shut down appropriately. So you don't have to handle that case. All right. So are we doing okay with this? Do we know how to do a select on multiple file descriptors? Sorry?
And I tried playing around with it and I wasn't really happy with my results.
Okay.
It kept telling me that, because I just passed it also a non-existent file descriptor to look at, and it kept telling me that there was stuff ready to read.
Yeah, you cannot give it
you
cannot give it non-existent file descriptors. You have to
Right.
give it file descriptors that are actually there.
Okay.
Okay, but that makes testing the program kind of difficult,
Yeah.
right? So what we'll do today is to look into certain ways to make testing this next program easier. Because we don't have any questions about the current homework assignment, we'll focus on this one. So what a particular tool that will be very helpful to test programs, especially when you have multiple file descriptors to monitor, is named sockets. Excuse me, not named sockets, but named pipes, FIFOs. So we'll go ahead and look for FIFO as a man page. FIFO is called a first in, first out special file. It is also called a named pipe. A FIFO is a special file similar to a pipe, except it is accessed as a part of the file system. Well, this part we kind of know already when we talked about the extension to file system, because one of the types of a file is that it is a FIFO, okay, or named pipe. It really is the same thing, it's just different names for the same thing. It can be opened by multiple processes for reading or writing. When processes are exchanging data through the FIFO, the kernel passes all data internally without writing it to the file system. In other words, it's kind of like a socket, but it's not a socket, okay? It is not a socket in one very important way. Even though multiple things can read from it and multiple things can write to it, there's no distinction. There's only one single pipe. So let's say I'm the server and we have 3 clients and we are trying to use a FIFO in the same way as a socket. As a server, I have no idea who wrote what to the named pipe. I can see the incoming stream of stuff, but it will be interleaved with stuff coming from all 3 different clients. Because to me, it's only one file descriptor. In the end, a named FIFO is only one single file descriptor, and it's not going to help me because I cannot distinguish who sent what content to me. I can only see the jumbled up content intermixed within all 3 clients. So in this way, a FIFO is not the same as a socket. It's only really intended for end-to-end communication and not for multi-process communication. The kernel maintains exactly one pipe object for each FIFO special file that is opened by at least one process. Okay, so before the first process, accesses it, it's really just it's non-existent. It doesn't have any representation. The FIFO must be opened on both ends before data can be passed. So if you only open one end, there's nothing you can do about it. Normally, opening the FIFO blocks until another end is open. Normally, opening the FIFO blocks until the other end is opened also. Oh, this is the blocking action, which means the opening call itself is going to block until the other end is also open. A process can open a FIFO in non-blocking mode. In this case, opening for read-only will succeed even if no one has opened on the right side yet. Opening for write-only will fail because it doesn't make any sense, because your pipe is connecting to nowhere, and if you open it for writing, it doesn't make any sense. But when you open it for reading, you can say that, oh, I'm just waiting for somebody to open it for writing, then I'll be getting something. Under Linux, opening a FIFO for read and write will succeed both in blocking and non-blocking mode. POSIX leave this behavior undefined. This can be used to open a FIFO for writing while there are no readers available. A process that uses both ends of the connection in order to communicate with itself should be very careful to avoid deadlocks. Well, that's kind of obvious, because you're reading from the same pipe as you're writing it. So if you are performing the read before you perform the write, then you're blocking yourself, because it just won't work that way. All right, so we'll go ahead and take a look at MK FIFO, which is a command to create a named pipe, a FIFO. Okay. I'll leave this one up like this, and then we'll go to today's folder, CIS 0314, CISP 453, and then use MK FIFO. MK FIFO is really just needing one single operand or one single argument to specify the name of the FIFO that we are creating. So this is also unlike named sockets. Named sockets are not created by MK socket or something like that. It is created by the bind call. Okay, the bind call in your program makes the file exist if it does not exist already. So in this case, MK FIFO is going to create a named pipe object. So in this case, I'll just say test FIFO. And then when I use ls, you can see that test FIFO is really hard to see because of the inversion of the color. This will do better. Oh, it's the same. Okay, let's try this. There's one system utility to display information of an inode. I just cannot remember what it was. Okay, that shows it a little better. Okay, so we have a file that has a 0 size, but this is a special one because you can see from the flag here, it is not a D for directory. It is actually a P here for pipe. Okay, P for pipe. Now, do we actually need to write a program to utilize a named pipe? The answer is no. We actually can use the simplest program to test a pipe. Which program are we talking about? Cat. Exactly. So now we can use one process to cat and redirect its input from test FIFO. Okay. What this command is doing is it's telling the operating system, okay, first of all, what does cat do? Cat is doing something that we have done already in one of our very, very first homework assignment. What does cat do?
Outputs to the screen. It reads from input and echoes it to output.
Yep, exactly. That's all it does. Okay, you can specify multiple input files, and therefore the name concatenation, because it will just write to the output the content of these files one after another. But by itself, cat really just takes whatever is coming from standard in and dump it out to standard out. In this case, standard in is redirected from the test FIFO named pipe. And there's nothing in the pipe yet because we are opening the read end of the pipe first, and it can open as per the discussion a little bit earlier. The man page says that in Linux this is permissible, but there's nothing coming in yet, so it's really just blocking and say, okay, I'm waiting for something to come in through the pipe. All right, let's open up another tab, and this time we'll do a cat and redirect to test FIFO. Okay, so now the pipe is completed. I have this end writing to the pipe. I have this end reading from the pipe. Let's go ahead and do something here. This is a test. Press the enter key, and then the other one sees the same thing. Okay, so this is one quick and easy way to test your program, because what you can do to test or to learn more about the select call is to open up multiple named pipes for reading. Okay, and then what you do is you just use this technique, and on the command line you just redirect the output to one particular pipe. So this way you can tell whether your program is working properly, whether it can properly wait for the availability for something to read, and properly locate which pipe actually has something to read. Are we kind of doing this okay? Are you understanding the concept of what we are trying to accomplish here? We're trying to write a sample program to test whether we understand how to use the select call on multiple file descriptors. And pipes can help because this is not sockets. It's a lot easier to deal with. You can deal with it using the command line, cat program, or just echo. Okay, I can open up another command prompt here and then say echo. This is from an echo command. And then I can redirect the output of the echo command to the same name pipe, which is test FIFO. Go back to my cat program, and it gets that too. Yep.
So it's not doing it character for character when you're doing cat, right? You have to push the enter key before it'll.
That is correct. It's because the standard in a teletype terminal is by default cooked, which means it doesn't send anything until you press the enter key, so that when you're not ready, you can use backspace to change content on that line. That's why it is cooked. It's because it's intended for human interaction. So sometimes you type something and you want to go back, you want to backspace and change it, and it allows that. Instead of sending out the backspace character also to the output, it just interprets the backspace character as erasing stuff in before the cursor. Are we still doing okay so far? Okay, so let's go ahead and write. Go ahead.
So, I'm sorry. You're gonna do what I was just gonna ask. So in the program, you're setting up your FIFOs much as you would files. Only you're gonna specify them as a FIFO instead of an actual file in the file descriptor. Is there a way when you're setting them up that they have to? Is there?
You mean to test select using named pipes for testing?
Yes.
Okay, that's what we're going to do next.
Okay.
So very good question. All right, so we'll go ahead and terminate this program, and this program also terminates because the very last right end of the pipe has closed. So the pipe, from the read end will also read end a file, and then the program closes because cat closes when the input file receives end of file. So we'll go ahead and write a program called test select. And this is going to be a very simple program. It is going to be, a lot of this stuff is going to be hard coded. So we'll have FD1 and FD2. And in the program, I would use FD1 equals open. I'm just going to hard code everything here. Test 501, and we'll use read only. FD2 is going to use test 502, and I'm also going to use read only in this case. And I'll just do one check if FD1 is greater than or equal to 0. And FD2 is greater than or equal to 0. And everything is good, and do the following, else something is wrong. I don't even bother to know which one I could not open. I just want to identify the problem and quit and not do anything in that case. And we want to look up with named pipes, what is the include file? Oh, not open. And to open, I think it's Unix standard. Nope, it's FCNTL. Copy and paste it. Are there any questions at this point? Nope. Okay. Yep.
Is there a way to get Y to not do that?
Not to do auto indent? Yeah, you can say set no AI. Yeah. AI stands for auto indent. So with mine, I think by default it does auto indent. So, but if you put this in .vimrc, then it won't do auto indent. But that also means when you say open curly brace, the next line will start from the very beginning instead of the same indentation as the open curly brace. All right. Well, I'm going to test the program just like this, because I want to do it incrementally. And we'll say mk50 test 501 and test 502 gcc-o test select.c, run the program, and it is blocking because of what? Remember when we read the documentation? When you open a named pipe from the reading end, the open call itself is blocking until someone is writing to it. Okay, so that means in order for this program to continue, I will have to use this test 501 and then use this one to cat to test 502. But as soon as I do this, it will finish the second open call. The second open call will return, and then immediately the program will exit. When the program exits, it automatically closes all the open file descriptors, which means these two programs will close at the same time because the read end of the pipe has closed. So we'll confirm that operation. Nope, that's not the case. Okay, the test program ended, but the two cat programs are still working because somebody is still opening the pipe. So they will remain open in this case. All right, so we'll go ahead and close that too. All right, are we still doing okay so far?
I'm confused. So you ran test select. Which,
Mhm.
Can we look at it again, please?
It doesn't do anything with the file descriptors once they are open, and then it just exits right away. Okay. Okay. So right here we're going to use a subroutine to deal with all the echoing from both pipes. Okay. So we'll say echo pipes pass FD1 and FD2 to these two, and then we'll try to figure out how to use the select call. Void echo pipes in FD1 into FD2. Now in your program, you probably don't want to use individual variables for each pipe. It's much better to use an array so that you can use indexing to control which one you're accessing. But in this test program, I can afford to do it because it's only a test program, and its only purpose is really just to illustrate how to use the select call. So you have to do something different in your own programs. All right, so let me just comment, what I'm going to do here. Okay, so over here, I will just say read from both pipes, echo content from both to standard out, and do this with select so that we don't wait unnecessarily. Okay, so this is what I want to do here. Do you think it's going to be a loop of some kind? It has to be a loop of some kind, okay? So if it's a loop of some kind, I also have to kind of indicate when am I going to get out of this loop here, okay? Exit when both pipes have closed, okay? All right. Well, since I don't know quite how to express that logic yet, I'm just going to say, while something, perform the loop. I'll go back and specify the condition later once I know how to deal with that. The first thing we have to do in the loop is to make a select call. In other words, the first thing we do is to make a select call and say that, okay, monitor FD1 and FD2, and do not come back, do not return until at least one of them has 1 byte available for reading. Okay, because in this case, we're only interested in reading. Writing is not important in this program. But in order to use the select call, you have to pass FD set to it. So that means, I'll just go ahead and do a man page on that one. Man to select. It has all the good stuff that you need. So we'll go ahead and include cis select.h first. Include cis/select. We also need to define our, the variable called FD set. In this case, we only need to define one for reading. That's what I will do first. FD set read set. Now this is uninitialized, so we also have to remember to initialize the set of file descriptors. To initialize, as we talked about last time, you use FD0 to turn the entire thing into zeros. Okay, so we'll go ahead and do that first. FD0, and in this case we have to pass the address of read set because the variable itself is of type FD_set, but the prototype is expecting a pointer to an FD set. So you have to pass the address of the variable and not the variable itself. For each iteration, I want to set it up so that it will try to monitor both of those channels. So that means I have to use FD set to specify FD1 as 1, and then say that, okay, set this particular element in read set. And then do the same thing with FD2. Like that. Are there any questions at this point?
So the reason you have to keep resetting them is that the select call is going to change those values.
Yes. When select returns, read set will only have a 1 in the bits representing the file descriptors where there is something to read.
Right.
So we're guaranteed that there's at least 1 bit being set because otherwise select should not return, but we don't know which one. So that's why before we call select again, we have to make sure that both of those are set again. Now if you don't want to have to do this, one other thing you can do is to use something like this. Just use one. You can use assignment to deal with it. You can say read FD12, and then you pull these two out of the loop and change that to FD12, FD12. Then inside the loop, all you have to do is to say read set equals read FD12. But that's kind of wasteful because this means if FD set is a really big object, then you have to copy the entire thing for every iteration instead of just changing 2 bits. So it's they do the same thing logically, but one is more efficient and the other one is less efficient. In your program, you cannot really use this approach because in your next homework assignment, you have to deal with 3 clients. But the 3 clients, which one dies first, you have no control over. So there's no easy way to do it. You really have to go through all 3, the data structure of each client, and see whether it is still alive or not. Are we still doing okay so far with this sample program? Okay. When this is all done, then we can go ahead and call the select function. So I would just put it inside the if, so I can check the result of the select call. And we are ready to do this. We're not quite ready yet because I have not computed an FDS. How do we compute an FDS? What does it mean? It's the largest file descriptor number plus 1. Okay, the largest. So of these 2, we just have to do see which one is the maximum. Now I already know which one is the maximum. FD2 is going to be the maximum because it is opened later. The file descriptor numbers are typically sequential, but since the system doesn't tell you for sure that it is sequential, you cannot rely on that fact. So the best way to do it in this case is simply to allocate another variable for max FD here, int max FD, and then we'll say max FD equals FD1 is greater than FD2, then we pick FD1, otherwise we pick FD2. Does everybody feel comfortable with the question mark and the colon? Good? It's basically if-then else statement combined into one single expression. This is our condition. If FD1 is greater than FD2, use FD1 as the value of the right-hand side of the entire expression. Otherwise, use FD2 as the value of the entire expression. That's basically what it means. Okay, now that we have that, we are ready. We say, max FD plus 1. Remember, it is not the largest file descriptor. It's the largest file descriptor plus 1 that you have to specify here. And then you have to specify the read set in this case. And then the other ones are just null. And since we are not timing out, that one is null as well. So we are using a lot of the default operations of select. Select returns a particular value. So if you read through this stuff here, the return value is, it will return the number of file descriptors contained in the 3 return descriptor set. So in this case, it can either return as 1 or 2, or -1 if there's an error. Let's go back to the program and see whether it makes sense that it will return 0, -1, 1, or 2, not 0. It doesn't return, go ahead.
Sorry, will you go through that again, the choices that it will return?
The choices in this particular case, in this very restrictive case, is going to be -1 if there's an error. It will return a 1 if one file descriptor has something to read. It returns 2 if both file descriptors has something to read. But it should not return 0 because returning 0 means it has timed out. And yet I did not specify the timeout structure here.
So if there were 3, if you were monitoring 3, it would have returned possibly 3 of all 3 of them? Or what is the, when you say it's going to return a 1 or a 2, how is that mapping back to our file descriptors?
If it returns a 1 if only one of the 2 monitored file descriptors has something to read. It returns 2 if both file descriptors that we are monitoring has something to read from.
But if we were monitoring 3, then it would return 3 of all 3 of them, or what's?
It's the count of how many file descriptors are ready.
Yeah, this parameter has nothing to do with the return value. This parameter is really 1 plus the largest file descriptor that I'm monitoring, which has nothing to do with what it is returning, because if I'm only monitoring one single file descriptor, but the file descriptor is 200 something, the return value can only be 1 because you can only report back and say one file descriptor is ready for a read operation. But just to be sure, okay, I'm going to do something like this. I would use an integer to store select result. So in case something happens unexpectedly, I can do it in a debugger and actually look at select result. So that way, I can debug my program a little bit more effectively. So So that's also one trick. When you don't know for sure what's going to happen, do not just put it inside a conditional statement and compare the result of a function call to something that you're expecting. Put it into a variable first. Because if you put it into a variable, at least you can go into the debugger, stop the program at that point, single step, and then look at the variable so that you know exactly what it is returning. So assuming select result is not -1, so let's say it's greater than or equal to 0, we already know it should not be returning 0, but I'm just putting it over here too. The next thing we have to do is to find out, okay, so which file descriptor has something to read here? Okay, now this is a good time to start to mention, okay, but what if one pipe closes? How do we detect the pipe has closed? And how do we remember that so that next time when we monitor, we don't monitor that particular pipe? Okay, so that's one question here that we'll try to answer later. But we'll just go ahead and do the straightforward code first, and then come back and check for the end of file or the closing of one of the pipes. So assuming that we're select result is greater than or equal to 0, we'll just go ahead and do some checking here. So we can use fd is set to check it. So we can check whether fd1 has something that is ready. There's no else here. There's no else because both of these conditions can be true at the same time. If you put an else here, that means if the first one is true, it will skip the second action. So definitely do not put an else here. These are two independent conditional statements. The first one is basically saying, if fd1 has something to read from, I'll go ahead and read it and echo it at this point. If fd2, then we check fd2 and see if fd2 has something to read from. If it does, then we'll go ahead and echo that too. So in either case, I know I'm not doing some very efficient coding here, but I'll just go ahead and do this part like this. So we'll say if just read fd1 into ch one character, and then go ahead and write it back to standard out, same character, 1 byte, and then I'm going to do the same thing with the other one. All right. Are we doing okay so far with this program?
You need to change it to FD2.
Sorry?
You need to change it to FD2.
Copy, paste, and paste. Copy and paste has this problem.
Make debugging fun now.
Oh yeah. Because the program would just block at that point because FD2 actually has nothing to read, or it will just keep echoing stuff from FD1, but not from FD2. All right.
I've got a question.
Yep, go ahead.
So we've called select,
Mm-hmm.
and it's come back to us because something has happened. There's been some activity
Something is ready.
that it wants to report.
Right. One of the things that we are monitoring has an activity.
Right. So then the FD is set on the file descriptor and the address of read set. I'm kind of confused about that call.
Okay, this call, it's basically the counterpart of this call here. This call is going to make sure that the bit corresponding to FD2 is a 1, and this one makes sure that the bit corresponding to FD1 is a 1. This one checks whether the bit corresponding to FD1 is a 1. If it's a 1, it returns a non-zero value. If it is a 0, it returns a 0. And it's because when select returns, it will change read set so that only the files with something to read from will have a bit of 1. All other bits will be zeros. So that's why I have to check to see which one actually has something to read from, so I can echo it to standard out. Now in this case, I'm also being very lazy because I'm assuming the write operation is not going to block. If the write operation can possibly block, well, there's really not much I can do, because if write can block, I really am not ready to check the next one anyway. So in this case, not not selecting on write is still okay because there really isn't much I can do about it. All right. So the program should work as long as we don't encounter a file. We'll go ahead and test it. GCC. Okay, it's complaining on line 20, unexpected expression before close parentheses token. Okay, we'll just debug it one at a time. Oh yeah, that will. Okay, how about that? That's an infinite loop, by the way. So this program is definitely not done yet. I'm just going to deal with it later on, because it doesn't handle a file. Okay, so we'll go ahead and try it again. And you can also see how one error can lead to all the other problems. And now we're ready to run it. When you run it, it doesn't really do anything because we're still waiting for the pipe to have a right end to open first. So we have to do this over here, cat to test 501, and open up another one to cat to test 502. And the program is still running. That's good. I did not even bother to print some messages, when both pipes are open. And now we are ready to type ABC. It should be echoed here, ABC. That's good. And I type DEF here. It should be echoed here, DEF. So everything is good. If I were able to type simultaneously on both of these terminals, then you can also expect the output of the program to be interleaved, because there's nothing that guarantees that the ABC has to stick together and the DEF has to stick together. In other words, I can see A, D, and then B, E, and then C, F. They can all be interleaved in any particular order. Yep.
Can you redirect to multiple files? Because if so, you can test that.
Hmm?
If you can cat to test 501 and test 502 in the same cat call, then you could test that and see how it actually works, potentially.
Can you redirect twice?
Can you redirect the output to two separate files in the same program or not?
I do not think you can redirect to two different output files.
Or maybe use, I don't know exactly how T works at this level, but you might be able to pipe to T and use T to write the file and then redirect standard out of T.
It will be pretty hard to actually see the interleaving because because we're doing it so slowly. Because in order for the interleaving to happen, the timing has to be right, and that's a really hard thing to guarantee when your program is running this quickly when there's a tight loop.
So you can do cat redirect 502 redirect 501 test 501.
You mean to chain
Yeah,
the
put
redirect? No,
another
cannot.
redirect.
No. The reason is pretty simple. You only have one standard out. So if you only have standard out, that means you can only redirect it once. You cannot redirect it twice. All right. So now let's go ahead and do something that we are not ready for. Control D. Okay. I'm closing this. And this program is running, but it's printing stuff. It's actually running. It's printing. It's printing end of line or something like that continuously. Okay. Let's stop it. Now, what do we do when we have situations like this? One, read the man page. Okay. Do you guys remember which man page I should be reading? As per the homework description of the next homework assignment.
Select or select type?
The select call actually has that information. So we'll go ahead and look for close. Nope. And the invalid file descriptor was given in one of the sets. Perhaps a file descriptor that was already closed or one on which an error has occurred. Okay, that's the only occurrence of closed. And also look for end of file. It's not there. Okay. Maybe it's in select tutorial. Look up end of file. close. Okay, right here. In the example below, I close this. Okay, let's read it from the beginning. If the functions read, receive, write, and send fail with errors other than those listed in 7, which is here. Okay, let's read this part first. The functions read, receive, write, and send, as well as the select call, can return -1 with error num set to the error number, E, INTR, or with error number set to E again, with block. These results must be properly managed. If your program is not going to receive any signals, then it is unlikely you will get E, INTR, and this program is not dealing with signals. We will talk about signals later on in this class, but we have not set up to do it yet. If your program does not set up non-blocking I/O, you will not receive E again. So we should not be receiving any one of these two, so we can just skip on to point 9. If one of the input functions returns 0, doesn't that sound a little familiar? Which one do you think is going to return a 0? The read call. Our read call is returning a 0 when I close the pipe on the other side, indicating end of file. Does that help with your homework assignment? Because in your homework assignment, you also have to detect end of file from standard in, and that's how you detect the end of file. Then you should not pass that descriptor to select again. In other words, when read returns 0, I have to mark that file descriptor and say that, oh, okay, do not use this anymore. This file descriptor is no good. In your homework assignment for next week, you have to mark the client and say that this client is no good anymore. Don't even talk to that client anymore. Because you're not only listening to the client, when you get something, you also have to echo out to all the clients. You have to remember that client is not talking anymore. Don't even try to echo to that particular client. Okay, so knowing that, now we can go back to our program and fix it.
So,
Yep.
for the, we were talking, was it for this one that's due on Monday that we have to detect if it just dies or flows or?
No, the one that is due on Monday doesn't have, it's not
Oh,
mixing
never mind,
read
yeah,
with
sorry.
select.
Never mind. I was thinking of this one. So we're keeping track of if they time out, or not time out, but if they close, basically, right?
Right.
And we're going to assume that they send a control D when it closes. Is that correct, or would it just be like?
You type Control D to close standard in to a particular client, so the client would know. That's for the new homework assignment.
Yeah.
For your current homework assignment, it's all automatic. There's nothing you have to do interactively, so there's
Yeah,
no Control D whatsoever.
I'm talking about the new one.
Okay.
But so, I think you were talking about that we need to detect if the client
Sees end of
doing-
file from standard in.
Well, if they just disappear, right? If they
Yep.
stop.
From the server perspective, when you try to read from a client's connection, if that read returns a 0, that means it is end of file, which also means that socket has closed. So you have to mark that client as not working anymore, so that you don't even try to listen from it or talk to it again.
So we're gonna pretty much assume that that's the way that the client's gonna stop accessing is when
Yes.
we're not just gonna all of a sudden just not receive anything from it. We're always gonna see.
A 0.
a zero.
Yeah, the read will return a 0. Okay, so now we know how to deal with this. Yep, go ahead.
Does that also handle client crashes with the kernel
Yeah.
essentially send an end of file on its behalf?
Can you say that again?
Yeah, if you wrote a client program that say seg faulted while connected,
Right.
what would happen?
If it seg faults, the operating system will close that program. When a program or when a process is closed or exited, force closed by the operating system, all file descriptors associated with that process will also be closed. In other words, the kernel does clean up after the program.
But will the select call then return saying,
Yes.
hey, with a 1 there?
Yes, it will return with a 1 corresponding to that file descriptor for the last time, so that when you attempt to read from that file descriptor, it returns a 0, which basically says this connection has now been closed.
Okay.
Yep. Okay. So what we need to do now is not to just happily say read and assume everything is good, because now we actually have to see what it is returning. So in this particular case, we can just say whether read is returning a 1 or a 0, and that can determine what to do next. If it returns a non-zero, which has to be a 1 in this case, we'll just go ahead and write it back. Otherwise, we have some other things to take care of. Because the otherwise is, well, we better remember FD1 is no longer around. I mean, we should not be reading from that channel anymore. So the first thing I do is to say FD1 equals to -1 to give it a non-reasonable value, unreasonable value, so I can check for that. The second thing I would do is to say FD clear. Is it spelled out all clear, or FDCLR? Okay, I knew it. So we'll have to clear. Oh, okay, I did it too early.
Yeah, I was gonna say, don't you want to do it before you set FD1?
Read FD12. Put it here. Why? Okay, so what I'm doing here is I'm marking FD1 as a non-functional pipe at this point. But before I do that, I also have to remember read FD12 is not going to have that bit set anymore. Which makes sense because I'm using read FD12 to set read set in order to tell select what I'm monitoring. So from now on, I'm not monitoring for FD1. In fact, I should not be even checking if FD is set from now on. So what I'll do is I'll just give it a guard condition and say FD1 is greater than or equal to 0 and FD is set. So that's a guard condition. If the first condition is false to begin with, it won't even bother with the second condition. And I will do the same thing here. And you can definitely tell right away that this is not a good idea, because I really should be using a loop with an array of file descriptors. Okay. But I'm going to finish the program. If that right, oops, else, okay, we have 5 lines to copy here. Paste. And change file descriptor 1 to file descriptor 2, which is something that you don't have to worry about when you do this in a loop. Okay. And now we are finally ready to specify when are we going to get out of the loop. Okay. When do we get out of the loop? When they are both less than 0. So we'll say while FD1 is greater than or equal to 0, or FD2 is greater than or equal to 0, stay in the loop, because as long as one of them is still alive, we have to stay in the loop. Okay, so I think that should do it.
So for the homework assignment,
Yep.
if one client drops off, are we assuming that we're not going to take on another client?
That is correct.
Okay.
You don't have to continuously monitor for incoming connection requests.
Okay.
So our program is really considerably simpler compared to a real server program, where it has to handle, a really constantly changing number of connections, new connections coming in, other connections closing, and so on. Our program is much simplified compared to that. Yep. But that's a good question. Good thinking.
We just wait for all 3 connections to connect, and then we start doing that.
Yep. And then we wait for all of them to die, and then the server can quit. Okay. So we'll go ahead and test the program again. Cat to test 501, cat to test 502, test, that goes back test, okay. Test 1, that goes back test 1. Now let's try to close the pipes, right? Close the pipes from this end. Close 1, It doesn't do the crazy thing that it was doing before, but we also have to make sure it's still echoing for that particular pipe. So we'll say test 2, and we see test 2 here. Now we close the other pipe, and the program should exit without complaining about anything, and it does. All right.
Can you go back to your source code for a second?
So, sorry?
Would you bring your source code back up again?
Yes. And I think the loop is the one that we want to look at. So one thing that you guys really need to do is to make sure that you don't do what I did, copy and paste the code. So I have 2 copies of almost exactly the same code. So instead of doing this, use an array. So this becomes, FD array, bracket, I, or something along that line. But in your program, I recommend that you don't even use an array of file descriptors. Instead, define a structure for each client. Okay, so that way you can keep track of a lot more information than just the file descriptor. So your program is ready for expansion later on. Okay. Any questions about this program?
Can you go up?
Sure.
No.
Oh, okay.
Sorry. Yeah, all the way. I want to see the okay, cool, thank you.
Okay. All right, but what about make? I did mention that you have to use make file in this particular program, so that I can say make and then make clean, so that we can do all this stuff with only just make. All right. Well, there's a long answer and there's the short answer to make. Let's go back to our browser. So we have pretty much finished all the topics for the next homework assignment, not just the current one. All right. So here we have a note on how to create a makefile. I'll go ahead and move this one to the folder, the topic for this homework assignment. So this way everything that you need are right next to each other. There you go. Okay. So this is the long answer. But it's also a very general answer that you can use for all of your classes. Not just this class, not just this project, but for all of your other classes. So we'll start with the application of the make program. What the make program is it's a program that can figure out dependency. And depending on what file has updated, it will try to make everything else updated as a result of running certain commands. And the make file consists of multiple rules. What a rule is it specifies a target. Okay, I'll just write it in the mouse pad, so this way we can capture it using the screen recorder. So mouse pad, there we go. So each rule, looks like this. There's a target with a colon. Sometimes you can have multiple targets. Sometimes you can specify a single target. But a target is nothing more than a file name. Okay, a target is basically a file name that says, okay, in order for this file to be up to date, quote unquote up to date, we have to monitor some other files. So now you have a dependency list here. The dependency list basically lists files that the target depends on. Okay, so target is the result of doing something with the files listed in the dependency list. The dependency list can be empty. It can be one item. It can be 20 items. It can be any number of items. And then the next line, starting with either a space or a tab, then you have a whole command block here. The command block consists of one or more commands in order to specify how do you create the target from the files listed in the dependency list. Yep.
I thought the command one had to be a tab.
Oh, it had to be at least one tab. You're right. So this has to be a tab character in order for that to work. You're right. Yep. Okay. But it can be one command, it can be multiple commands, and sometimes it can be even no commands because certain things can be implicit. Okay, so in our case, in this particular program, let's say we have the program output as socket2 as the executable. Socket2 would depend on socket2.c because that's the source file. And if you want it to be very simple, you can just say, this is the command to go from the source file, socket2.c, to the destination, which is the target, which is the executable. So you can say -gcc-o socket2.c, and that's pretty much the minimal thing you can do with this particular makefile. Now, obviously, this will interfere, so you can use a pound symbol to make a line, a line of comment, so the rest of the whatever is on the right-hand side of the pound sign will be ignored because that's considered comments. But I also want to make you, use make clean in order to delete all the object files. So what you do is to say, this is clean. Clean depends on nothing, and what it does is to remove, in this case, just socket2.o. Okay. Now this particular makefile is very simplistic, and it works. However, it is also very brittle. It's brittle in the way that if you change a project, if you change to have multiple files, you have to change it. If you start to use header files, you will have to change it. If you have, it's just very, very brittle in the sense that, if you make any changes to the project, this file will have to be changed accordingly. Okay, so this is a short, introduction to how to use a makefile. Well, let's go ahead and save this just to be sure that it works, right? So we'll save it to today's folder. And save it here. Oh, I have to give it a file name. The file name has to be makefile. I think there's a variation, but one of the file names that make automatically look for is makefile with the uppercase M. Does anyone know what are the other variants? I think lowercase m makefile also works. But there's a certain priority list, if it finds one, first it will use that one. But makefile with the uppercase M definitely works. So I'm going to go back to my command prompt here. We don't have socket2 in this particular file, so I'll just do the lazy thing and just move, test select.c to socket2.c, and then say make. Oh, it does it automatically. I say make again. Nothing to be done because socket2 is already up to date. If I change the time code of socket2.c and type make again, it's going to recompile because it wants to bring everything up to date. It doesn't even care whether the file is actually changed or not. It just looks at the timestamp to make sure that everything is up to date. So that's the easy solution for the homework assignment. But for people who want to use makefile for bigger projects or want to make it more flexible, the class notes that I have prepared here has a little bit more than just that. So let's go to an example, very simple examples. Let's move up here. We'll go take a look at the last few versions. Okay. This is a very, kind of nasty looking, makefile. What it does is it defines, what is the compiler. First, for one thing, it defines the compiler. It also defines the flags that you want to pass to the compiler. The flags you want to pass to LD, the linker. It also allows you to specify some files as .c files and some files as C++ files. And the executable is called main. These are variables inside the makefile. The main target is the executable, which means if you type make and then press the enter key without specifying the actual target, it will pick this one up as the default target. And most of the time, people when they type make, they just want to have the executable done. So this is appropriate in most cases. What is kind of strange here is we have these things. Okay. the percent symbol is basically a wildcard. So what this is saying is blah 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 dot d as a file name depends on blah 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 dot c. In this case, it means socket2.d depends on socket2.c. But how do we make socket2.d in this case? Well, there's a little gibberish of command here. Now this command, or this block of commands, it's not just one, it's actually a block of commands, is used to generate the dependency of this particular .c file. If your .c file has pound includes, of files that you are defining yourself, instead of using the angle brackets, you use double quotes for the pound include. This will figure out all that dependency and put it into the .d file to indicate the dependency of this particular .c file. I do the same thing with .cc files. The C++ files also have the same thing. I have clean. And here is also something that is kind of strange, because what it does is it's including a bunch of files. It's saying that look at this variable, cscr or c's source. Look at this variable. Replace all the .c's with .d's. And then include those dependency files. So with this particular setup, whenever I want to add a new source file to the project, all I have to do is to redefine either C source or CC source. And it will automatically figure out everything. If I start to use a new header file, I define a new header file, and then I start to pound include that new header file in one of my .c or .cc files, make automatically takes care of it. Okay, so this is really quite universal. I find this particular template to be very, very handy, because all you have to do, as a programmer, you cannot really get away from having to specify the source files of a project. That part is really, really hard to get away from. But once you specify that, the dependency on the header files is automatically updated, which I think is a big, big plus. Because otherwise, if you forget to specify the .h files as a part of a dependency, very nasty problems can happen. Because you can have one object file compiled using the old version of the .h file, and have another object file compiled under the new version of the .h file. So if the .h file is defining a structure or something along that line, or constants for arrays and stuff like that, that means there's no agreement between the object files. One object file says, as I understand it, struct A has these attributes ordered in this particular way. The other object file will have a different understanding of the same, quote unquote, the same type, the same structure. So when you pass a pointer of a structure, there's no problem. The compiler doesn't complain. A pointer is a pointer. But the way the content of the structure is interpreted will not be consistent across the object files. So you end up with very, very mysterious problems. Because the attributes will just be modified and accessed inconsistently. And that's why this is a good way to do it, because the dependency of the .h files, of the header files, that's automatically handled, and you don't have to worry about it. Yep.
So main.c and array.c are just program files or source files that you created, right?
Yes.
In this situation.
Same with UI.cc. That's also a source file that you define.
And so what you're saying is kind of in my experience with Make, it doesn't. Anytime you just have the source file, it just goes and grabs the includes your .h files, or what? How does?
But not the dependency. Okay, let's take a look at. Okay, we are almost running out of time, not quite. So I will just go ahead and. Okay, if I do pound include in double quotes this time, socket2.h, and let's say in socket2.h, I just define some really simple stuff. Okay, like okay, so I'll just go ahead and define blah is 23. Okay, So when I go back to the source file, it would actually know that the blah is defined as 23 as a macro because it's pound including
Yep.
socket2.h. If you forget to specify this in your make file, like this one here, then when you update socket2.h, it will not trigger a recompiling of socket2 because it is not listed as a part of the dependency. That can be very bad. In this program, it's not as bad because typically when you make a change to the header file, you usually make changes accordingly in the source file, and this is a single source file program, so it's not a big deal. Not as much of a big deal.
So when you're setting them up as dependencies, it's basically saying if either of these change, then you
If any one of these files changes, you have to remake socket2. So the proper way to do it is to list socket2.h as a part of the dependency. But people forget it all the time because we don't think of these things as important. What if socket2.h pound includes yet another header file, which pounds include yet another header file? You have to mentally track down all those things and make sure that you list everything that it includes, which is very tedious and is very prone to errors because every time you make one little change, you have to remember, okay, do I have to make changes back into the make file?
Takes a lot of time.
Exactly. On the other hand, this will automatically figure it out because it's using a very obscure option of GCC, which is -M to figure out the dependency. In other words, GCC is actually the tool that's spitting out the dependencies and say, oh, okay, according to my analysis of of the preprocessor directives, I know that this file potentially will depend on this file, depends on that file, depends on that file, depends on that file, and it will spit out a rule that is already in the format of GCC, of the make file. And that's why, at the end here, all I'm doing is to pound include those files that are generated by GCC itself that tells me about the dependency of the source files.
So when you're using the percent signs, that's basically taking each.
It's a wildcard.
Yeah, from the list.
Yep. Yep. And you can extend this even more to deal with assembly. In other words, if you have a multi-source file project where some files are in assembly, some files are in C, and some files are in C++, as long as you know how to intermix those particular languages and whatnot together, you can have one single make file to deal with everything. And the only thing you have to do, if I go back to here, the only thing you have to do is to identify what are your source files in C, what are your source files in C++, and if you have assembly files, identify those as well. And then the make file will automatically take care of the rest, which I think is a big time saver. So I use this template a lot myself because I'm lazy. All right, we are running out of time, so try to think about the next homework assignment, especially if you get the current one done already. Think about the next one, and then on next Monday, we'll continue on and talk about some additional stuff like threads and signals and stuff like that. Have a nice weekend. I know it's kind of early to say have a nice weekend, but this is our last class meeting before next Monday.